right, hello everybody and welcome to the next Nix Hour. So today we have a question right here in the meeting. If you have questions yourself, always feel free to interrupt or leave a message and we'll try to get to it. So today the question is comes in form of a paste note here, and that is that so there's an overlay on OpenSSL to override a flag on OpenSSL, and there's a Python overlay, and it creates a new Python version that's a weak Python that uses the weak over OpenSSL. It's configured here. Now the question is, why does Python need this self equals weak Python, which is just the same as above here? So I think let me try to. Actually, I'm not sure. Can I replicate? Just try to make use of this and see if it works. Let me try this. Let me open a weak Python here. Just paste this in here. I guess packages. Let me use my local Nix packages here, and then just do packages.weak Python. Now this will probably attempt to build OpenSSL. Let me just check this. I'm gonna Nix build this file. All right. Actually that finished very quickly, which I guess there might. I'm not sure if this was actually verified to work. Let me just double check this. So I'm currently formatting this manually. There's also an RFC in progress. Actually, maybe I'll just briefly show this. RFC 101, if you're interested in kind of how the standardization of Nix formatting is going, feel free to check that out. It is being worked on by me and PyGamesD every week, or second week actually. So yeah, for now I'm just formatting this fairly manually. So we have two overlays that are applied in sequence. So first OpenSSL and then Python. Now the Python overlay, let's look at that. So we have a rec here. Rec is a recursive definition of an attribute set. So this means the variable you define in here are available to use. So I guess this is why the weak Python is used here. I would generally recommend avoiding rec here, and instead preferring, in this case, self.weakPython should give the same result. So overlays are extending a fixed point if we want to be technical, and the fixed point in the end will set weak Python to the same thing as here. So let's just check here. We have super.python 3.1.1. In this case, we don't need to use super here. We can use self. You only need to use super when you're overriding that attribute itself. And in this case, we can also use self here. So actually, all of this can be changed to self. And then the OpenSSL overlay, let's also take a look at that. Here, we go OpenSSL. We can also use self here. There's nothing wrong with this, same reason. And then configure flags. I guess we might want to, well, it seems to work. If there isn't a configure flags set already in the derivation, we might want to add an or clause here, so it doesn't error when the attribute doesn't exist. All right, let's try to build this again. That actually still builds. I'm a bit surprised. So actually, let's check why is it not building anything. So let's compare this to the standard Python. So I'm gonna do standard is packages.python 3.1.1. That's the one we're overriding here. And the changed one, that's the weak Python. And now I'm gonna try building standard. And the changed one. And it is indeed the very same thing. Now that is I guess a good question, how you can actually figure out why something is not changing. When something is changing, it's kind of easy to know. but in this case, it's a bit harder. So I guess let's just try to dig a bit into Python, and this should also answer the main question here about self. Well, the quick answer, I think, is that self is just there because of historical reasons. I don't think if you were to design the Python ecosystem the way it is now from scratch, that you would need this. At least I think that would be the case. Oh, and actually, I think I have a clue here. Actually, do I? No, these are all results and looks from before. All right. Okay, so let's look at how Python stuff is defined. And so I'm gonna dig down manually into all packages for now. All packages is where all the packages, in fact, almost all the packages are defined. Where I say all the packages, not all the attributes. And so we can just search for Python equals here. Got a comment that should have been reproduced first, but no, that's fine. I think it's good to just also try things out and see why they might not do what we expected them to do. So in this case, I'm going to search for Python, and we can't find Python equals. Probably it's in an inherit. Not sure if I can find it this way. Well, okay, we can't find it, so that's not great. Instead, let's use Nix REPL, and let's do a built-in unsafeGetAttrPos on Python and pass packages. So this is and I guess in this case it does not work. So this would normally give you the location of where attributes are defined, just like this. In this case, we have no clue, however. I think that might be caused because Python 3 is an alias. So we could check this out. So let's say we just defined an X, and now we try built-in.unsafeGetAttrPos. Where is X defined? Oh, and that is actually also null because we don't have a file in this case. So let's create a simple file.nix. Let's just say x equals 10. And now with this file, we can do unsafeGetAttrPos, import the file. Now we get this. But as soon as you kind of transform these attributes in some way, so let's say we add a built-in.mapAttrs, and let's just say we increase the value by 1. So the value is value plus 1. And so it's the same attributes, but changed by 1. Now this doesn't work anymore. Even though if we just were to import this, we'd still get the attributes. And this is what's happening here as well. So I believe in top level aliases is where all the aliases are defined. And in here, we will probably find a Python. I'm not sure if it's going to be in here. Python, oh, it is in here. So yeah, Python is defined like this. And so, okay, this is the same as we have the x equals 10 before. But at the top of this file, we can see that there's a mapattrs here, which transforms all of the aliases and therefore kind of removes that location information. So it doesn't work in all the cases, but we can, in this case, just use Python 3. And this actually points us to the Python 3 one. So the line is 17,258. Let's go in here. I'm going to use, kind of forgot the syntax in Vim for how to go to a specific line.
Paste the number, then G. Go.
Well, if I paste the number, it's just going to do that.
Or just colon and paste it.
Oh,
In command mode, you can also just type the
No,
number.
without the comment, just the number. Without G, just
Move
the
the G here,
Oh,
or
like this.
you
I
do
see.
a line number G in normal mode.
Yeah. All right. Thanks a lot. I didn't know how to paste one, but that's useful now. So we finally got to the Python definitions. These are, of course, aliases as well. It's actually not aliases are in the aliases file. Okay, we have more aliases, and actually let's try to find the Python 2.7 one. And now I guess we can use this way of trying to find these. Actually, no, it doesn't work. Well, we could dig into this a bit more using this. So we could say Python 2.7, where is that defined? And actually that 3.12, let's try this again. So like this, nice. And we finally got to the meat of it. Python is defined via Python interpreters. Actually, this is also kind of a good place to yeah, so this would be a good place to mention that Python, it's easy to have multiple versions of Python in overlays. So let's just say we wanted to change the default Python packages set or Python 3 packages. And so if you just did super.pythonpackages.override, I believe might work. I believe then there's like an overrides here, which we can use and so on. This would be slightly problematic because you still have a Python 3.packages, which also exists. And this won't have the override because Python 3 packages is an alias to this one down here. It's defined like this somewhere. And so, okay, we might say, let's instead do Python 3.packages equals this, but then you soon start running into, right, we actually want something like the above here. So we might do it like this, Python 3.override. But now, again, because Python 3 is actually not, Python 3 is actually Python 3.11 or something like that. And Python 3.11 is actually not that either. It's pythonInterpreters.python 3.11. So if we want to make sure we actually get to the root of it and override all of these, we would have to override the Python interpreters. But every nesting level you introduce here will kind of cause more complication because it's harder to override it. I'm not actually sure if that's even working here, because Python interpreters has a callPackage here, and then we'd have to look into how is it actually defined. So we'd go into here, default.nix, and we'd see it's a big Latin statement wrapped in parentheses, which is a bit weird. Basic question, does the Python 3 packages alias, why does the Python 3 packages alias exist? It's not shorter than writing Python 3.packages. The Python 3 packages alias exists at least partially because you want to be able to refer to it, or it's nice to be able to refer to it as an argument. It's kind of what people are used to. So if you go in packages, search for Python 3 packages, we'll find a lot of examples like these. And honestly, there's no reason this has to work this way. We could also just use Python 3 here and then Python 3.packages here. And honestly, that's probably better. But actually then these functions here in the current Nix packages conventions should represent the arguments that this is kind of the user interface, the API, that people are supposed to be able to override easily. And so instead of Python 3 here, we should ideally take Python as an argument. And unfortunately, currently it's really annoying to change this, but then if you want to use Python 3 by default, you'd have to go into top level Python packages. And then this is queue page view. queue page view. You'd have to go in here and say, actually, this is Python package by default, so this shouldn't be necessary, actually, yeah. It would be necessary for all packages in here. So Python equals Python 3. You will see a lot of these in here, which set the default Python version to something else while maintaining the same API for users to override, so that users can just do .override override Python equals some version instead of having to do Python 3 equals something. All right, but anyways, let's get back to the the interpreters thing. Here's all packages Python interpreters right here. Yeah, so we were looking at the default .nix file here. What does it return? It returns a, looks like it's a bare attribute set. Yeah. So in this case, there's no like special override function you could use. In a lot of cases, like we'd have an override or something here, but in this case we don't. Although actually it is called with, it's a bit more tricky than that because it is called with callPackage here. And so callPackage will actually add it will add an override, it will add an override attrs, but it won't allow you to override attributes just like this. Anyways, the thing you'd have to do in the end is use Python interpreters equals super.pythonInterpreters and just do a normal / merge. And here we'd have then Python 3.1.1 for the specific version you want to override. All right. And then in here we'd have the actual override. So Python interpreters dot Python 3.1.1 dot override, like this. Because this is super messy, I wouldn't really recommend doing this. There is I mentioned this before as well. There is this new pythonPackagesExtensions, which allows you to add packages to the Python package sets. Although I don't think it allows you to override the Python itself, although it might actually work too. Yeah, let's get rid of this again here, and this one. But yeah, we're closer to actually answering the question here. So we want to look into what the Python package stuff here does. Let's go back into the default.nix here and just see what it looks like here. So, okay, we can see the self argument being passed in here as well. And actually that gives me a clue here. The spliced packages stuff in Nix packages is how cross-compilation works. And so it's a bit magical how it works. But basically, there's different package sets for the different host platforms you want to use, and they're passed somewhat automatically. But in cases where you have these package sets where you might like get arguments from up here, so there's some callPackage integration that makes sure to pass the right to kind of splice these packages together. So you have all the available ones. There's some make derivation magic that picks the right one. And this can sometimes mess up when you have these package sets. I believe that's why they're passed here directly in order to ensure Python packages can be cross-compiled. Ideally, of course, this shouldn't be necessary. Spliced packages, actually, where does spliced packages come from? It comes from here. All right. Let's also just look at where self gets used here. So all of these call some CPython in this case. If you go in here, look at the default.nix. Oh, I'm going here. Default.nix. Oh, did I? That's kind of weird. Well, let me go. Packages development interpreter Python. We had CPython, we had 2.7, and then default on Nix. So all of these get the self argument. Where is it used? Self is here. And then it gets passed to pass-through fun, which is another function passed in from the environment. Pass-through fun. Let's get to that. As always, it's a bit of a pain to dig into these definitions in Nix packages, but we have the pass-through fun in here. So just explains it here. Puts a pass-through for all the Python interpreters. Pass-through are attributes in derivations that do not affect the derivation build. They're just attributes in the resulting attribute set. So in here, self is Python on host for target. So again, seems related to cross-compilation. And if we look at this here, Python packages fun. So I believe it's used to create packages based on a Python version, which is passed into here. And we can see the splicing also being somewhat manually set up in here. There's also a make new scope, which is used here. This is a fairly new function. Previously, a make scope existed, which could be used, which did work, but I believe it didn't work with splicing. And this is a function that does work with splicing and cross-compilation, but it's a bit annoying to use. So yeah, I can't give I don't know the full details of how this works. Yeah, and actually considering that, I feel like just doing this would probably break cross-compilation. Yeah, and actually we should, what if we try to do that more properly so I can test whether it works here. But let's see, we saw the spliced packages earlier. Let's see if that exists in here as well. So let's just do a Nix build on spliced packages. That does exist indeed. And now, I guess in this case, we would want to use, what would we want to use? I guess just this then. Yeah, and I guess let's inspect this a bit. What is the difference between the normal weak Python and normal Python and the spliced one? So let me just inspect this a bit. Let me do Python 3. See what this is. Some store path, and what about spliced packages.python 3? That is the same thing in this case. I have a feeling this will be different if we cross-compile. So let's try this. Now I'd have to refresh my memory on cross-compilation, but I believe there's packages cross. Yeah, AR64 multi-platform, that sounds good. And then Python 3. Actually, I don't want to build it. I just want to see what it would evaluate to. So I'm just going to do a Nix instantiate. Now the spliced packages.python 3. And that is the exact same thing. So I don't think that's quite it. Oh, actually, I think I know the answer, and we can maybe demonstrate this here. So let's say you have a file and you use callPackage. I think that's a missing link. So let's say we have hello, and then we say callPackage. We have a hello.nix file where we define this. Let's also use packages. Now, hello, and actually I don't want to use a file in this case. It's a bit annoying to have to swap between files. So I'm going to use a feature of callPackage that allows you to just use an inline function in here. But actually, let me do this hello fun. So I'm going to declare this as, let's say, I guess, yeah, let's do the Python thing here. So let's just get Python 3 and see what this is. and just expose this, inherit Python 3. And also I want to check spliced packages. So I'm going to do spliced equals spliced packages.python 3. All right, now we call package hello. All right. I think that looks good. Well, let's just see what the result of that is. I'm going to do a nix instantiate on this file dash a Python 3. Oh, like this. And I'm going to do one on the spliced one. That is still the same. So let's try to do the cross-compilation. I hope I can achieve something that's different now. So it is AR64 multi-platform .callPackage. I hope that also works. Python 3. Oh, packages crossed not defined. All right, and spliced. It's still the same. So I'm out of ideas, to be honest.
Maybe
I guess as a
different
last
platform for it to take effect. Like right now, you build. I guess you
I think it
cross-compile
should
from Linux to
be.
Linux.
Yeah, we could. Oh, I guess I don't think that would be the reason. But I guess let's just verify or check the cross-compilation kind of statistic. So file.nix, I'm gonna do, let's just do nix REPL. So I loaded this package set. Actually no, I just loaded packages in here. I'm gonna load packages.packages cross. And I don't need to do this in here. I can just do nix REPL and then packages. Let's say p equals packages cross dot AR64 multi-platform. And now I can check stdenv dot host platform, build platform, and target platform as well, though not always applicable. So host platform, well, a bit hard to read this as a rough approximation. So platforms have a lot of fields, but roughly it's this. I'm not sure if that always corresponds to a full encoding of the set here, but that's for another time. So yeah, we indeed have different platforms here, and yeah, that seems to indeed be cross-compilation if we were to try to build it. There is another. Well, it could potentially be that it only applies, right? There is some stdenv.make derivation logic to try to make cross-compilation work. Let's maybe take a real brief look at this. So stdenv is in packages stdenv in Nix packages. And I think it's in the generic one. Well, there's various files here. I don't want to go too deep into stdenv, but in generic, there's the make derivation. I'm just going to, so this is the implementation of stdenv.make derivation. I'm just going to search for splice. Yeah, so we can find something that implements cross-compilation here. So, oh, I see. So apparently every derivation has a spliced attribute. I presume that's in the callPackage case, which then has different attributes for the different ways in which you need it for cross-compilation. And depending on where you put this in, so in this case, we have deps build. I'm not sure. Oh, native build inputs. That's the one most people are familiar with, and the build inputs here. So they use different versions of the dependencies. So native build inputs uses dependencies for the host, where build inputs uses it for the target. There is some documentation on stdenv and cross-compilation in the Nix packages manual. So there is standard environment, a chapter on that, and cross-compilation in here. this does explain it to some degree. There is some, it's not trivial to read it, although it has improved maybe. Yeah. All right, so this looks pretty good. Just, I'm not sure if I answered the question very well, and I'm not sure if you should actually do this here. I guess the right thing would also be to check the Python section in the manual. I think it's a bit unfortunate that this is a single page. I believe there is also a manual rendering of multiple pages. I'm not sure where that is right now. But Python, we can look at languages and frameworks here. All of the ones are here. And Python is down here. The Python section in particular is fairly large, maybe a bit too large. It contains various types of documentation here. And I just want to search if there's a reference to self in here. And this is actually pretty poor search experience. I think I can get around this by just highlighting something here. Yeah. So self, this is all overlays, self.o. Here's an example that shows that you need this. Okay. Override my Python. Self is there's nothing that explains it from what I can see here. No.
Should we try it outside of the overlay? Just without overlays, just see if this builds.
Yeah, I mean, we can try this. So just like, I mean, so it looks like the overlay actually doesn't really do much in this case. So I guess we can't actually reproduce it because of that. I mean, let me briefly see here. We have an OpenSSL override on Python here. So override overrides the arguments of the call package that created this. And if we want to figure out that, unfortunately, we have to look at the source. Actually, there is no, there isn't a great way to discover this, to be honest. So yeah, let's look at the source again. That's in Python development interpreters, Python default. So here we have the call package. It calls this. Let's actually get to the right version in case they're different. Here, default. All right, so these are all the arguments that you can override. And OpenSSL is indeed here. I wonder if it's not used by default. I mean, we could figure this out actually by just doing a throw here. If OpenSSL isn't used, it will give an error. So let me do this packages.python 311 here and remove this again. And then do a nix build or nix instantiate is also good enough of this file. So yeah, this does indeed evaluate, even though we put a throw here. Actually, let me get rid of this. It's a bit noisy. So let's also just verify that this weak Python is, oh, I mean, in this case, yeah. I didn't even use the weak Python, so. Okay, so that actually does throw. So, okay, in this case, it's not, that isn't the problem. Is it that the default version of OpenSSL is the same one as the weak one? I guess we can verify this by using override with an argument here. So just to get the old arguments. And then I can do, let's just do a trace here. Let's do trace old.outPath. And let's trace versus self.weak OpenSSL.outPath. All right, let's see. And we get an error. Will we get an error? Oh yeah, we get an error. Why do we get an error still? Attribute outpath missing. That's fair enough. Old.outpath, of course, doesn't work. Needs to be old.OpenSSL. And now we can see trace this one versus this one. These are indeed different versions. They have different starting, a different hash. So we do supposedly change this. Is it, did I break this? Was the rec for some reason required? I hope not. So weak Python. I guess we need to verify that it actually is changed again. Did remove this, didn't I? So let me add this back. Inherit. Actually, I can just do packages here. Then I can do -a weak Python and the Python 311. Yeah, that is indeed still the same store path. So I guess what we could also do is look at the derivation and see exactly what OpenSSL version is actually included in there. So to do this, I'm gonna do a Nix instantiate again of this. Oh, actually, what is the file called? Nix instantiate weak Python, and I'm gonna do weak, or actually the number one, 311. I mean, it is the same result. We can still take a look at what it contains. So Nix show derivation is fairly useful for this. So we can paste the path of a derivation here. It will give us a nice JSON showing everything about the derivation. So it doesn't actually build it. It just shows us the recipe. Underneath, these derivations have a format that's a bit harder to read. You can also do that by just looking at the file. But that, as you can see, well, it has some kind of Python-like structure. I believe you can even import it into Python directly, or almost directly, and it mostly works. Definitely not Python, though, and show derivation is the kind of preferred way nowadays to do it. Although, I need to point out the next command is still experimental. But yeah, we can pipe it into JQ, get some color output as well. Just going from the top here, I guess you can have multiple of these, but in this case we have just one. We can see all the environment variables to the the arguments of the builder. We can get all the environment variables, a whole bunch of them. The environment variables usually also contain the build phase and stuff. So in this case, we have the whole post install here. And just like this is really hard to read still. So what I tend to do to make this more readable is to use JQ. We first need a kind of to recurse into these derivations, then recurse into env, and then into the phase that we want. Now we have direct access to the post install, and now pass the -r, so you get the raw output without the JSON wrapping. Now you can actually see what happens in the builder, all without having to find the Nix files of where it is defined. All right, and then if we go back up here, something else we can see is the inputs to the derivations. So derivations can depend on other derivations and specific outputs of those, as we can see here. In this case, we can hopefully find OpenSSL. Yes, it's here. But also they can depend on files directly. So these are not derivations, they're just kind of files copied into the Nix store. And these are tracked separately. Right, and so if you have patch files, or if you include a file, if you directly refer to a file in the build, it will be included like this. Then also outputs, the outputs of the derivation, name as system. All right, now, yeah, the OpenSSL, I guess let's look at this here. Input derivs. And let's massage this a bit. Let's get keys. That works pretty well. And -r. And oh, and I want to do it like this. Okay, now I'm realizing that almost the exact same thing can be done with nix store-q of the references, I believe. So let's try this. Let's get the store derivation here and do this. And we get almost the same list. And I believe this also includes the files here. So yeah, virtual env permissions.patch. So not just derivations. But otherwise, I believe this should be the same listing here. If we wanted to be exact, we would probably use like unique and order them and compare them. Anyway, so OpenSSL. So the actual one that is included here is the old one here, the one that we are trying to override. So weak Python in here. So we did this. We did a trace of this. Let's just verify this again. So this does actually, yeah, weak Python. So, and actually I'm realizing that, yeah, we don't have the same store paths. So the one we saw earlier was a derivation path. So in here, this is a P8VG. Derivations have two paths. One is a derivation path. The other is the output path. And actually multiple output paths, because each derivation can produce multiple outputs. And we can also see this if we wanted to use show derivation again. We could do this like this, get the individual ones, and then I believe it's outputs. Yeah. So we can see OpenSSL has multiple outputs, and I guess one of these is the one we saw. So let's do weak Python. The Python here. So we can see, so it's bin one specifically here. So that's 1HMN. And neither of those are matching this one. That is a bit surprising. All right, so I guess this is not the actual, we're not getting the bin output here, are we? Or the bin one might be the default, but let's just make sure. Let's do .bin and .bin as well here. Okay.
I think it would use dev output or lib. Oh, dev and lib.
Oh, right, we did use. It looks like the default one was bin already, right? This was obvious from this here already. Oh yeah, we have another question. So hopefully I can wrap this up here, and maybe if we have time, we can get to that one as well. So built-in trace. Let's override this. I'm just double checking everything here to see if we missed anything, because to me, this should work. So let's look at the definition here. OpenSSL, how is this used? If OpenSSL is not equals null, then use OpenSSL legacy. This is very weird. But so if OpenSSL is not equals null, so if we define OpenSSL, then OpenSSL, it's always defined. Oh, that's interesting. Yes, actually, OpenSSL prime is only used in here. That is very confusing, and I think that's almost a bug. So we need to override OpenSSL legacy here, seemingly. I'm just going to get rid of this. I am pretty sure this should be fixed with this. Weak Python, it didn't rebuild anything, but it did change. Oh yeah, we are using Nix instantiate. That's why it doesn't rebuild anything. But it did change something. So I think finally we figured out the reason why we couldn't reproduce it here. But this is fairly intricate, and I'd be inclined to think that this has to be a bug somewhere. We could also just do like a git blame here to figure out where this was changed, if this is a recent thing. Oh, actually, we're blaming the wrong file. But yeah, you could use a git blame. So maybe let me take a look at the question here in the chat, briefly read this. Very beginner, which just started using Nix. I'm still a bit confused on how to use it to manage dependencies for my Python project. I would like to create a project that depends on Python's gdal numpy 3 blah, blah, library. So gdal should be installed on the system for it to be properly compiled. How would I use Nix to create this and a Docker image with the right gdal version? Yeah, that sounds like a good question. So gdal, so generally when you need something specific in Nix, you want to first go to search.nixos.org. Also linked, if you go to the main page, there's a search box up there. And so you just want to search for the package. So in this case, gdal. I'm going to use the latest release here. So we have gdal, that's indeed in here already. There's also a Python package for it. Different Python versions are displayed here, but they're available for all the Python versions. And let's also check the version. So in this case, we have a slightly newer version than you specifically need. Generally, I'd recommend always trying to use the latest version of dependencies. They usually have the most fixes, and nixpkgs is generally fairly good at not removing old versions that still have a use. And otherwise, if older versions are still useful, or if the new version are like backwards incompatible in very drastic ways, you will find versioned. Actually, let me not do it here. Let me do it like Linux packages, for example, which actually should be backwards compatible, but Linux, well, Linux, there's a bunch of versions. Anyways, so we want to use gdal here, and I'm just going to use, let's assume we want to use the latest version for now. Now you want it to, right, for it to be installed on the system. So in Nix, we generally don't install things on the system. Instead, we write either a derivation that then contains the dependency inside of it. So you can then have build commands inside the derivation that make use of it. Or you can also get environments with the required dependencies. So let's look at the environment example first. This is the easiest way to get started with just creating a Python package. So let's say I guess you can use Flakes. I don't think Flakes is useful, but that's another discussion. You don't need Flakes to make use of development environments. And But if you want, you can do that too. In the end, you just need a way to refer to packages. Traditionally, it's something like this. I'm going to make this a bit more pure. You don't need to do this in flakes. So overlay is kind of ridiculous. In flakes, it would look something like packages equals nixpkgs.legacy packages.system. Something like this. In any case, you can have a packages in the end. And I'm in the shell.nix file here. I'm going to use packages.makeShell. So that's a function that is useful for shell.nix. Actually, shell.nix in flake for flakes, or equivalent for flakes, is dev shells. You can find this in flakes tutorials if you want to go into that. And so make shell is a nice way to just get an environment. We can, in here, the kind of easiest way is to say packages. And so in this case, we might say, well, I want to add packages.python3. All right, now that we have that, let's actually move the shell package to a Nix Hour directory. Otherwise, I don't really want to use the Nix packages one. All right, so we have it here again, import Nix packages and so on. And by the way, here, I guess if you don't use flakes, you also want to use pinning. So fetch tarball. Actually, I should link to something just like pinning on. Well, there's a 0 to Nix example. This uses flakes. I guess if you want to use flakes, that works. There is also a NixOS.wiki article. The wiki is not super well maintained as far as I know, but I do think there's a pinning article that gives a decent overview. So
Nix.dev maybe?
I'm not sure if Nix.dev covers it already, but I can maybe just brief mention that Nix.dev has recently become official, and the documentation team is working on improving Nix.dev and moving or trying to centralize the documentation resources in here. Yeah, so recently assigned copyright to the NixOS Foundation. Yay. All right, so that's, yeah. Can you repeat that?
Pinning Nix, the menu on Nix.
Sorry, the audio quality is a bit bad right now. I'm not sure if it's on my side. Something about the menu on Nix.dev. I think let's continue. Feel free to write in the chat. I couldn't quite understand you. So yeah, now with a make shell, you can, well, in the traditional stable Nix commands, it would be Nix shell to enter the environment. Actually, in my case, I'm gonna unalias Nix shell because I like a C shell thing. So Nix shell enters you into a bash shell where you have the packages available. So here, which Python will point to the Python that I specified in the Nix version. Yeah, and oh yeah, there is a pinning Nix packages here apparently. Thanks, Ian. So yeah, I think I should actually link to this one. That's useful as well. Here. All right, and so in this environment, you have the Python available, but the Python by default doesn't have any packages in here. So if you do Python and do import dal, I'm not sure if that's a module name actually, might be different, but it doesn't exist. And so to actually add packages to the environment, the nowadays recommended way is to use python3.with packages. And so note that I added a parenthesis in here. let me not do that for now and see what happens. So the argument that you pass to with packages is a function. The function gets all the Python packages. And so I'm just gonna, the return value should be a list of the packages in that set that you want to have available. So in this case, I would do what was it again? gdal in here, like this. And you could add other Python packages in here. All right, now if we just do it like this, we'll see a problem. And actually, this is just going to do Nix shell. Actually, let me use Nix shell run Python apply. So in this case, we will see a kind of confusing error, to be honest. This should be improved. Actually, I have a PR open that improves this. But you need to add wrapping parentheses around this, because otherwise it's going to treat this as two separate list items. So this will be the first list item, this will be the second. But we want just a single list item containing both of these. All right, now once we do that, the Nix shell works. It should download stuff. That looks pretty good. And it downloads gdal here as well. Yeah, and then now we're almost out of time. There was also a NumPy requirement, but I think for start, this is, well, it's a start. Now just to demonstrate, let me exit the Nix shell here, re-enter it. And actually, I want to Python import gdal. I guess it's not the module name, gdal.
It's OSGeo.
Oh, import OSGeo. Oh yeah, that works. Yeah, that works. We have a basic environment here. So we are out of time, but so this is only the start. There is various other ways of going further with this. There is packages. If you just have a script and you want to do this, you can look at packages.writers, which has, I believe, Python something. You can look at, well, the entire Nix packages manual in here. It's a bit much, but the Python section in here. So if you go to language frameworks, Python again, that shows you a lot of different things you can do with the Python ecosystem in Nix packages, especially also packages like Python 3.packages.build Python package, which is what you'd want to use for building a package that uses this as a dependency. Yeah, and I think that's about it. Thanks for joining. I'm going to stay around here a bit